Hello, this is Omar from Mrs. Kirch's 5th period class, and I will be going through a problem finding parts of a rational function and graphing it. Here we have this function given, and we can automatically deduce it will have a slant asymptote because of the degree difference. Bigger on top by just 1 does mean it will have a slant asymptote, and we can automatically cross out and ignore horizontal asymptote because we can only have one or the other for these two. To find the slant asymptote, simply divide the top by the bottom through long division shown here. Ignore the remainder and take your answer. Make sure it is in slope-intercept form and write it out in that form. To find the vertical asymptote, all we need to do is factor the bottom and set the terms equal to 0. Here, however, we have two terms that cancel each other out after we factor them out. We need to make note of these as we will be using them later. For our vertical asymptote, we get x equals 4. And to write the limit notation, we need to remember that these signs basically mean from the right and from the left. So if we take a look at a real graph from a graphing calculator, we can see that from the left or from the negative, the graph starts going down, or negative infinity. And from the right, or the positive, the graph starts going up, or into positive infinity. We write the limit notation as seen here. To find the wholes of the function, we use the term that was cancelled out and set it equal to 0. Here we get -3, and to find the y value, we substitute it into what is called our simplified equation. The simplified equation is basically anything that was left after we canceled what could be cancelled. This will be very important for finding other points of the graph. Once solved out, we get -2.1, and then we write the whole out. We will skip the graphing for now because I prefer graphing at the end. Now these three are much easier to find. Our domain is basically every infinity paired with our vertical asymptote, seen here. Our x-intercepts are found setting the terms in the numerator of our simplified equation to 0. In this case, we get 0, 0, and 2, 0. Our y-intercept is found by setting each x equal to 0 in our simplified equation. In this case, we end up with 0, 0. Before we begin to graph, we must know at least 3 points for each section of the graph. Here I divided the chart by the left section and the right section of the graph. The left section only needs one additional point because both our x-intercepts are on this section of the graph. The right, however, needs 3 new points, so we can pick any x value as long as it's to the right of our vertical asymptote. To find these points, either use a graph or a table on your graphing calculator and write them down. Finally, we graph our equation. Here, we have both parts of our function. Right here is our vertical asymptote, and here is our slant asymptote. We also have each 3 points we found from our chart that helped us graph, including our 2 x-intercepts right here. Also, we have our hole right here that the graph actually never touches. That's it for this video. Thanks for watching.